odd function is an even function, and the product of two even function is an even function. First of all, let's take the product of two odd functions. According to the definition of the function, f of minus x is equal with minus f of x. We already know this statement. And now what we have to know here is, let's take the other function. So this is one function is an odd function, and the other function is according to the definition we are taking as an odd function minus g of x. So now what we have here, if we take the product, it means f of minus x, so one even function, times g of a minus x, so the other odd function, are equal with a minus f of x because I have to deal with the negatives. Let me take a double parenthesis here, minus a g of x, g of minus of x. So that's why I'm using a double. But negative times negative is a positive, and this is going to be equal with the f of x times g of x. But as we see here now, this is a even function because it's a positive. The argument is a positive. So what we are proving here, if we have a two odd function, the product of two odd function gives us an even function times g of x. So we can write this way, and we can end this proof. And we already proved this one here, so this is okay. And we're going to prove the other one. The product of two even function is an even function. According to the definition of the even function, f of minus x with argument minus x is going to be equal with the f of x positive function is going to be is f of x. And now if we are taking the second function, g of with the argument minus x, according to the definition of the even functions, we get g of positive x. And now here we have a f of minus x, so it's negative, time, so the product of g of minus x is going to be equal with the f of x times g of x. So both are positive, so even we get a positive function. So and this already proves here the product of a two even function is an even function. So in both cases we already proved those two statements are true, and we proved those statements.